Now let's solve some linear equations where distribution is involved. I'll go through this first example. Here I can simplify the left expression, and so I do. I'll begin by distributing and getting 4a plus 4. Next, on the left, I'm going to combine like terms. 4a minus 3a is just a, and 4 plus 4 is 8. To solve for a, I'll subtract 8 from the left and the right, and I find that a is negative 10. To check my work, I'll go back and replace both these a's with negative 10 and simplify. The left side does become negative 2 like it needs to, and therefore I've found my solution. Try this one. First, we'll need to distribute the 2 and get 2y minus 10. Continuing to simplify on the left, we'll get 8y minus 10. Now, I'll add 10 to the left. That will isolate my variable term on the left. I'll also need to add 10 to the right. On the left, I'll get just 8y. On the right, I'll get negative 24. To get just 1y, I'll divide the left side by 8. I'll need to divide the right side by 8 also. And I'll have y is negative 3. Returning, substituting, and simplifying shows I do have the solution, since both of my expressions have become negative 34. Try this one. Please notice you're going to have to distribute both on the left and on the right. Distributing on the left gives us 3x plus 18. On the right, we'll get 10 minus 5x. To combine my variable terms, I notice that the coefficient 3 is greater than negative 5. And so I'm going to combine them on the left. To do that, I'll add 5x to the right so that these will go to 0. Of course, I have to add 5x to the left also. On the right, I'll simply have 10. On the left, when I combine like terms, I'll get 8x plus 18. Now I'll combine constant terms on the right by subtracting 18 from the left and from the right. I'll simplify to get 8x equals negative 8. I'll divide to get just 1x on the left. And after reducing the common factors of 8 on both the left and the right, I'll get that x is negative 1. Returning to the original and substituting negative 1 for every instance of x, and then simplifying, I find both expressions become 15, so I'm pretty happy with my solution. See if you can work your way through this example. I'll need to begin by simplifying both the left side and the right side. On the left, after distributing, I'll get 8 plus 12t minus 1. And on the right, I'll get negative 8 plus 11t. I'll combine like terms on the left to get 7 plus 12t. Since my coefficient of 12 is greater than 11, I'll subtract 11t from both sides, and that'll give me a single term of t on the left. Now I'll subtract 7 from both sides to combine my constants on the right, and I'll get that t is negative 15, and after replacing and simplifying, the check looks good. How about this one? On the left, I'll distribute to get 10 plus 2x. On the right, I'll distribute to get negative 3x minus 18, or negative 3x plus a negative 18. It's up to you. I can combine like terms on the right to get negative 2x. Since the coefficient 2 is greater than negative 2, I'm going to combine variable terms on the left. I'll do that by adding a 2x to the right and also to the left. On the right, when I simplify, I'll get just negative 18. On the left, I'll get 4x plus 10. To combine my constant terms then, on the right, I'll subtract 10 from both expressions and simplify and find that 4x is negative 28. Last, to get just 1x, I'll need to divide by 4, and of course I'll do that on both sides. When I reduce, I'll get x is equal to negative 7. And then I'll check my work. In both cases, I'll get negative 4. So negative 7 is my solution. How about this one? Be a little careful with sign issues right here. On the left, I'll distribute to get negative 6y plus 30. On the right, I'll get negative 2y minus 6. Negative 6 is less than negative 2, so I'm going to have my variable terms on the right. And to do that, I'm going to add 6y to both of these expressions. On the left, negative 6y plus 6y will be 0, so I'll just have 30. On the right, I'll get 4y minus 6, or negative 6 plus 4y. It's up to you. Constants now will get combined to the left. That means I'll need to add 6 to both expressions and simplify. Last, I'll need to divide by 4. And after reducing, I find that y is 9. And here's my check. See how you do on this one. It's a difficult problem. On the left, I'll need to distribute and get negative 2k plus 8. Be careful, make sure it's a plus 8. Plus 3k plus 12. And on the right, I'll get 4k minus 4. Combining like terms on the left, I'll get k plus 20. Since the coefficient 1 is less than 4, I want my variable terms on the right, so I'll subtract a k from both expressions and simplify. Now, I'll add 4 to both expressions and simplify, and that'll give me a single constant term on the left. Last, I'll divide by 3. That way I'll get 1k on the right and 8 on the left. When I check my work, I find both expressions simplified at 28, so I'm confident in my answer. Well, that concludes this video where our linear equations involve distribution.